Hello, so today we're going to learn about the quadrilateral family tree. So in the first place, what is a quadrilateral? A quadrilateral is a four-sided figure. So over there we have a lot of four-sided figures. Today we are going to look at how the quadrilaterals, parallelogram, the rectangle, the square, the rhombus, the kite, and the trapezoid are all related. So the defining attribute, meaning the mandatory, can't be this type of quadrilateral if it doesn't have this, a parallelogram, is that it must be a quadrilateral that has opposite parallel sides. So as we see, the parallelogram has all four sides, and the opposite sides are parallel, marked by the arrow. So this side is parallel to this side, and then this side is parallel to this side. We know that these sides are parallel to each other because if we extended these sides up and then down like that, but a little bit neater, we see that the lines would never intersect. That's the definition of parallel lines. So under the parallelogram branch, I drew a rectangle and the rhombus. We're going to look at how the rectangle and rhombus are parallelograms and also how they are related to the square. So a square is a rectangle and a rhombus, and it is also a parallelogram. The defining attribute of a square is that it is a quadrilateral that is equilateral and equiangular. So equilateral and equiangular means that the sides are all the same length, marked by these little tick marks, and that all the angles are going to be the same measure. And if we know that a quadrilateral's interior angles must be 360 degrees, then if there are four angles, every angle is going to be 90 degrees because 90 times 4 is 360. Well, then how do we know that this is a parallelogram? We know that this is a parallelogram because if all the angles are right angles, because a right angle is 90 degrees, then we know that all the sides are perpendicular. So all the adjacent sides are perpendicular to one another. In order to have perpendicular sides, then there must be parallel opposite sides. So therefore, we know that the square is a parallelogram. So on top of my square, I have a rectangle. A square is a rectangle because the defining attribute of a rectangle is that it must be a quadrilateral with all right angles. As we said, all of a square's angles are right angles. Therefore, if that's the one defining attribute of a rectangle, we know that a square must be a rectangle because it meets the defining attributes of a rectangle. A rectangle is only sometimes a square. When the sides of a rectangle are all the same length or equilateral, then it is a square. But because it is not a defining attribute of a rectangle to be equilateral, it is not always a square. Next, we have a rhombus also on top of the square. A square is also a rhombus because the defining attribute of a rhombus is that it must be a quadrilateral with all four sides congruent. Because a square is equilateral, it is always a rhombus. As we can see with the drawing, all four sides of the rhombus are congruent according to the slash marks, as are the squares. A rhombus can sometimes be a square when all of its angles are right angles. But because having right angles is not a defining attribute of a rhombus, it is not always a square. But now how are the rhombus and the rectangle related? Well, a rhombus can sometimes be a rectangle when its angles are right angles. As we have said, the defining attribute of a rectangle is that it's a quadrilateral that has all right angles. But because having right angles isn't a defining attribute of a rhombus, it isn't always a rectangle. A rectangle can also be a rhombus when all of its sides are equilateral. But because it is not a defining attribute of a rectangle to have all equilateral sides, then it is not a rhombus. For both of these shapes, though, when they do meet the attributes of one another, so when the rectangle can be a rhombus and the rhombus can be a rectangle, they end up being a square. The rectangle and rhombus are under the parallelogram tree because they have parallel sides. The opposite sides of both a rectangle and a rhombus are parallel. As we have explained when I explained the parallel sides of a parallelogram, we can do the same for a rectangle and a rhombus. Under the quadrilateral tree, we have a kite and a trapezoid that are not under the parallelogram branch. This is because that their defining attributes do not include having parallel sides, nor do their defining attributes imply that they're going to have parallel sides. When we had a square, for example, we knew that the sides would have to be parallel because their sides are perpendicular to one another, making right angles. In order to be perpendicular, like I said, we have to have parallel opposite sides. However, a kite is connected to the rhombus because a rhombus is always a kite. A kite's defining attribute is that it is a quadrilateral with two congruent adjacent sides. In a rhombus, all of the adjacent sides are congruent because the defining attribute of a rhombus is that it has all congruent sides. So as seen with the tick marks, so the adjacent sides of the kite, we have two of the sides that are congruent and then another two sides that are congruent. With a rhombus, all of the sides are congruent. Unconnected to any of the other quadrilateral shapes, but still connected in the quadrilateral tree because it does have four sides, is the trapezoid. The defining attributes of a trapezoid is that it must have exactly one pair of parallel sides. All parallelograms must have all opposite sides be parallel, or must be like a kite and can sometimes have opposite sides parallel when it is a shape such as a square or a rhombus. So now let's look at this quadrilateral tree as a whole. As we see, many of the figures are connected, and that is because they are all quadrilaterals or four-sided figures.